I mean, so I think one of the closest analogs, right, to this is, I mean, climate modeling, where sure there may be lots of planets out there with climates, but we only have data from one, and maybe we'll be able to wait and get more data, but that defeats the point we want to know now, right? And I'm just wondering if, I mean, so I thought one of the problems with the uniqueness that you were pointing to originally was closely connected with the number of free parameters in the ansatz, right? Yeah. Because, I mean, right, I run the simulation, and then I say, oh, look, great, I can make it match the data, but there's free parameters in my ansatz. And then what I can't do is then say, oh, let me fix the free parameters, and now go check on some other universe and see whether it still fits. Okay. What climate modelers do, of course, right, famously, is they try to divide their data sets, and they tune their parameters for one data set, and they see how well those parameters work on another data set. Now, you mentioned that a little bit with different spectra of light coming in. Right. I took you to say that the problem is for every spectrum of light, the parameters are different. So, but does anyone ever do that where, let's say, okay, you get some new telescopes online, you get some new data in some spectrum, take half that data, tune the parameters, and then see how well it works on the other.
Yeah, statistics are not good enough yet, but okay. That's the reason why observational astronomers are really pushing for larger telescopes and more data, because then they can partition the data,
right,
in ways that will allow that kind of testing and honing the model.
Cross-validation.
Yeah.
It's related to what she said. In physics, you usually have like these laws and boundary conditions. Where boundary conditions are related to very specific conditions of that environment. But we are generally looking for the laws that apply for all different things. So in principle, what the limits that you have to access to just one universe, okay, versus that had we had access to like other universes, we would distinguish, okay, the laws that would apply all different things, and the specific phenomena, the data that comes from each universe is with different specific contingent like conditions and boundary conditions. So since we have just one, right, and we cannot wholly distinguish what is arise from contingent or boundary conditions, and like from the kind of universal laws that we are kind of seeking. So there seems to be kind of fundamental like things that we could miss.
Maybe. I think it depends on your view of laws. I don't know. My view of laws is you give your best theory of everything, and your laws are whatever the best way of systematizing all that is. That is what your laws are. So I'm not. So I mean, if you have some other conception of law, like there has to be this special kind of thing with some nomological structure or something antecedently, then maybe I could see a problem. I just have trouble seeing a problem with that because I just say, well, let's just figure out everything we can figure out about the world, and then our laws will just be whatever fall out of the best systematization of that. But it depends on how you think about laws, I guess.
I want just specific questions. Yeah. So you talked about this gravitational balancing, and your data graph has very sharp like peaks and so on.
That's just a representation.
Okay. So how do you distinguish? How do you eliminate the possibility that there would be just black holes?
Oh, because the masses that are associated with these clumps, that's not a free parameter. So that's a consequence here. The deflections that you measure actually directly give you the masses. And those masses are incredibly large. And you know that they are not. There could be a background, you know, the bump that I showed you that was sort of smooth for that cluster. So okay, you saw something that looked like that. And so this smooth distribution, because remember, that could be, I mean, little black holes could be part of that inventory. I wouldn't know. I mean, I am sensitive to granularity on very particular scales. I know what scales they are, so I can go to the simulation on the same scale and compare the granularity.
Yeah, because this speculation comes from what you said, that your simulation with huge mass.
Compared to the mass of a single particle in the simulation bears no relation whatsoever to the mass of a dark matter particle itself. It's an aggregate of huge ensemble. And we have no idea how to think about how that aggregate, the single body to many body, what complications there may be in that.
How are we doing on time?
Yeah, so maybe it's a good time to end. Right? So,
Well, thank you.
everybody, and
Thank you.